you for joining us. In our topic today, we'll be looking on the laws of indices. Now, the laws of indices is a convenient tool in mathematics that is used to compactly denote the process of taking a power or a root of a number. If we have an expression 3 times 3 times 3 times 3, we know we can compactly write this as being it's the one set of 3, 2 set of 3, 3 set of 3, 4, and write this as 3 to the 4th power. Okay? And similarly, if we have a number, say 100, we can also write this as 10 squared because we know it's 2 sets of 10 that are squared to equal 100. Also number 64, if we are to compactly write this or to write it in the index form, it will be 2 to the 6, meaning that it would be 6 sets of 2's to equal 64. Alright, so in this case, the 2 is the base and the 6 is the power. Alright, power are indices, that would be the plural form of the word. Alright, so there is a law, the first law of indices, which is the multiplication law, and that is when we multiply quantities with the same base, we add their indices. Looking on this general formula, which says a to the m multiplied by a to the n. What we see here, seeing that these are the same base, right? What we can do is to add the power, and that would be equal to a to the m plus n. And that would be how we solve the general formula. That is our general equation. Looking on this example over, let's use this marker, where we have 3 to the second power being multiplied by 3 to the 5th power. Alright, so we know that both these are the same base, so we can apply the next law of multiplication, which is we are to keep the same base, 3, and add the power, which is 2 plus 5, which is equal to 3 to the 7th. Alright, and we know this is similar in saying we have 3 times 3 times 3 to the 5 is 3 times 3 times 3 times 3 times 3, right? And it will be 1, 2, 3, 4, 5, 6, 7. That's how we got 3 to the 7. Alright, looking on another example in which we have 5 to the 3 times 5 to the 4. Okay. Same base, we can add the power, which is 5 to the 3 plus 4, 3 plus 4, and that's equal to 5 to the 7. Okay. Alright, so we have another example, r times r to the 4th power. Alright, in working on this example, what we know this is equal to is r times r to the 4, 1, 2, 3, 4. In counting the sets of r, we have 1, 2, 3, 4, 5. You know this is equal to r to the 1, to be 1, plus r to the 4, that is equal to r to the 6th power. Okay. Similarly, if we add p minus 3 times p to the 7. Yeah, applying the formula, that would be P A minus 3 plus 7, and let's write the minus 3 right here. Now minus 3 plus 7 is equal to P to the 4th power. Okay. And let's look on another example. We have a 2x cubed times 5x cubed. Okay. Alright. And below there is a number or coefficient attached to it right here. We can't say separate because it's the same base being multiplied. What we do in multiplying it, we have 2 would be still there, times by x to the x to the x. Then that is being multiplied by 5 times x to the x to the x. Alright. If we were to multiply everything out, we would have 5 2's, 10, and x to the 3 plus 3, that will be equal to 10 x to the 6. Okay. Alright, and that would be our first law of multiplication, in which the general formula says a to the m multiplied by a to the n is equal to a to the m plus n.